What's up, guys? Chris with Croft CNC and CNC for Newbies. Um, don't know what happened with the initial startup video. For some reason, it kept looping. It locked me out of unmuting my microphone, and I couldn't stop the setup. But today's video, I'm coming to you from the garage. We're going to go over um, how I set up. How I align, how I set my offsets, and how I set my max travels for my rotary machine or my rotary axis. The machine that I'm using is my CNC for Newbies 4896 automatic tool changer machine. However, a lot of this stuff will be pretty much universal for any of you guys. You'll just have to change your measurements based on Z-axis travel, your rotary axis, chuck size, jaw size, and platform size. So that's some of the things that I do for each part and each machine when I set these up, especially on a somewhat temporary setup like this. So let's flip this around and get started on going through this. Okay. All right, guys. So I have your typical K12 self-aligning 4-jaw chuck rotary. You can get them on Amazon for $250 to $300. It's pretty typical. Comes with the rotary axis. It also comes with the tailstock. I put a aviation connector on it myself just to make it quick plug into my controller. Nothing major there. My controller, I'm using UCCNC. So you'll have to do stuff according to your controller. But it's fairly simple, fairly easy. So the first thing that I'm going to talk about, this board here is my square board. It's a simple bump stock. It's a simple bump stop. As you can see, I cut a line with the x-axis and it skimmed the front of the board. That way the front of this board is pretty straight across in reference to the axis, and that allows me to have a nice parallel guide to the x-axis. And then if I get a good square, I can put a square on there and put a parallel guide for the y-axis. Okay. So that kind of gives you the basic square board. If you have bump stops, or if you need to make a bump stop, you can see those videos on YouTube. If you have a bump stop, you can utilize it just like you're squaring up material. The next order of business was setting my alignment for the rotary axis, which is the most important part for me. And on these, on the bottom, you have a valley. And then these black marks here are actually where my tailstock meets up. That is the offset for my tailstock, which is about just under a quarter of an inch. It's 0.2 thousandths or 200 thousandths. So I have the width measurement there. I have this platform measurement, and then I have the offset for my tailstock platform. Okay. That's all stuff that I wanted to know, but you don't have to. For me, a real simple, easy way was to take a square or take a level that has a a nice parallel face, lay it down on my bump stop, and then take my platform and lay up to the square. Okay, this does a couple things. So very first, I can take a pencil, and as you can see, I have a line that goes all the way across my bed. And that's my rotary axis line for the outside teeth. So this is as far towards the bump stop as it's going to go. All right. That's kind of an important part so that you know the offset for your tailstock. Okay. Next, I move my rotary axis in place, and you'll see a second line. That second line here actually goes with the inside face here on that valley. Okay. So now I have 2 points of alignment, and I can go straight through and straight back. And that's good because that'll tell me if my tailstock is aligned or misaligned. Okay. So I can get a pretty good square right there. Hey, we've got XXX18.online with news site with hot girls. Guess what? You're blocked. Sorry about that, guys. But anyways, so now I have some alignment marks for my tailstock. So this is squared up on this face, okay, by this level here on the bump stop. I can move this back, and I know that my offset is 0.200. And what that does is that allows me to take some playing cards, set in there. So now I know from this level face with that stack of cards, I should have perfect alignment. And I pretty much do. It works out really, really good. There's that. Well, I got the spindle in the way right at the moment. Let me move that. We'll go continuous, Y back. Okay, we got that moved. All right, so now I could take my stack of cards. I could take my tailstock. And when I do this, I like to have those 3 pads pressed against the card. And as you can see, I have my 0 point, and it's in line with the center of the chuck. And I did that. I have some lathe tools that I center everything on. I have Pro Edge tram bar for the rotary axis or lathe, which is a really nice tool. But you can simply put 2 live edges, one in your tailstock and one in your chuck, and you can make sure the points touch, and you'll be assured that the plane straight across is in line and that the height is in line at the point. Then you can just take a dial indicator and sweep this and make sure the back end's not lifted or lowered. Okay. Pretty simple to do. So now I've got my rotary axis where I want it, and I'm able to align my tailstock quickly based off of the bump stop and the level and the stack of cards. Pretty good. I mark out my lines. Now I know kind of where everything's going to go. the next thing is actually setting up where the rotary axis face is for the jaws, so I know where my tool is going to stop before it touches these. And then also, in my case, I had to do a rotary material offset because I have extended gantry plates for my Z-axis. I have a thicker Z-axis, and that will actually interact with these jaws when the jaws are opened up. So I had to make a couple different lines to designate where I'm going to put my rotary axis. So the very first thing is I can move my rotary axis into place right there. And I have a line that designates where it's going to sit based on that. And then I actually drilled and put in these 1/4-20 nutserts into the wood. So basically I can quickly slide it in, put my bolts in. Now it's somewhat there. I can push it forward for alignment that way. And then I can put my level right up against there. And now my rotary axis is set with the offset line right here. Pretty simple, straightforward. I have a little bit of adjustment because these are 1/4-20 inserts. I can this is a 5/16 hole. I can shim that forward and back a little as needed. Now, I also need to know where this jaw will interact with this plate, because this is the furthest part of my Z-axis, and when it comes down, we don't want it to hit the furthest point of these jaws. So for me, my offset was 3 1/8 inch. So my rotary material start, the minimum rotary material will be right here. Okay. So that's very important for my setup, that I do not have my material start any closer to the chuck than this. And I'm going to talk about some glue blocks and stuff like that here in a second. But the material, whenever I do my design work, I have to add 3 1/8 inch to the material start if I'm going to start at the Y0. For me, I'll probably just start at the or X0. I'm sorry, because I'm setting this up for X right now, and then I'll set it up for my Y for long turns. But anyways, I'll probably use center point in a spire, and then go from there. So as long as I make sure I have 3 1/8 inch offset material, I'm good, and we can go from there. So now I can bolt this down, and I torque this, and I'll have to check my torque wrench as to what I set these bolts at, but I torque them down fairly snug. I haven't been able to move the rotary axis yet, so it's not an issue. Next thing is for my statuettes. I know I'm going to have 12-inch material plus 3 1/8 inch. That's, let's make it 16. So I can actually measure from the front face here 16 inches, and then I can extend my tailstock out just a little. Okay. So if I extend that out, say to there, I can now set up my tailstock like so, and then bolt that down. Once that's bolted down, I know from this point out to this point, I should have my regular material, and then from this point to this point will be added material for my offset. Okay. Now you may run into a situation where, in my case, I only have so much clearance for my rotary axis. As you can see how close it is to the bed frame, it sweeps, but it just barely clears. So this is the maximum diameter material that I can put in those jaws. And for me, that maximum amount of material is 1 5/16. Actually, it's 1 3/8. But what I'm going to do is I'm going to use what are called glue blocks. Glue blocks are just a piece of material that gets glued to your cutting material to set in the chuck. Okay, it's basically a sacrificial piece that gets glued. It can break off. It can be cut off, so on and so forth. But my glue blocks, I use 1¼ inch diameter by 1¼ inch length. And that's what goes inside here. It gives me enough material sticking out that it clears this front face. So by the time it's said and done, I might end up with 16.5 inch length for a 12-inch piece. Okay. And that gives me all my clearance and everything. It does give me a little bit of wasted material, but you could take those wasted material pieces and turn them as globes or something of that nature. As you start moving forward, you can use them as cube pieces for cutting blocks, cutting boards. You can use them as bump stops for different fixturing and stuff like that. So that's all up to you. But you will have a little bit of wasted material here that just won't get used. It's par for the course for setting up like this. Okay. So now we have the ability to spin the chuck all the way around. It doesn't contact the Z-axis. It doesn't contact the spoil board. And then on top of it, it's bolted down. It's nice and solid. And you have your offset for your tailstock. Now, with all of this, I took my tailstock out to the furthest length that it would go. And I basically put it where I was able to ride this T-track in front of it, which is right here, or get away from this T-track, which is right here, and then on the backside right here. And then I use number 10 lag bolts to put it in. Once again, this is a sacrificial board. All the stuff that I do to it, I'll basically do and redo and put holes all over it. As you can see, I have designations written all over. I have different offset measurements. This is 2 inches from the home position is where the start of this board is, so I can align stuff off of that edge. I just have a lot of different stuff going on here. So that's my max travel of my tailstock. So now I know from here out, my max material is 23 inches. Okay, so I can get 23 inches in between from the closest face here to the closest face here. All right, so I can, in this orientation, I can set up 23 inches of material. This is good for table legs and stuff like that. Now, the next thing is the biggest material I can turn in this orientation. And let's see. There's my tape measure. So now I have everything aligned. I have my offset needed for design. I have my offset needed for glue blocks. And now I have my maximum length of material. Now I need to be able to get my maximum uh, turning material. What I mean by that is the diagonal measurement of a square piece or a um, regular diameter of a round turned piece. Okay, in my case, I I have some 3 3 3/8 fence posts that I'm going to turn, and uh, that's 3 3/8 front face. So I might have to shave that down by hand a little, or put a glue block on there that will maneuver it enough that it can be rounded over. But your maximum half measurement is to the center of your jaw, which for me is 2.5 inches. So overall, the I'm sorry, not to there. My bad. From the center of the chuck, not the jaw. So it's 2.5 inches. Okay. And that gives me a 5 inch maximum turning diameter. Maximum. So I keep mine at about 4 3/4 max for this setup. And that's just me. So if you take a diagonal measurement of, let's say, this fence post, and this is just a regular fence post from Lowe's, Home Depot, we're at 4 3/4. So that's pretty much the maximum setup that I can run for turning a square piece. All right. So I can cut that into multiple pieces for turning the Jesus and Mary statuettes. And that's basically where we're at with this whole setup. Okay. So just to go back over, showed you how to align your rotary axis. I actually denoted 2.322 inches from this edge to this edge, which is the measurement of this level. To get the jaws to clear the chuck movement on the spoil board, I need a 1 1/4 inch by 1 1/4 inch wooden puck to go in there, and I need to be able to glue my material to that. I use CA glue, super glue, and then just go from there. I make the pucks on the machine using leftover 2x4 material. I just draw an X, screw it down to the table, and cut around it. And I just make a round cut. You can also buy pre-made dowels. They're a little bit more expensive, but they work just as well. I like putting a hole through the center of them and then drawing 2 diagonal lines where they intersect, draw a little bit of a divot into the material, and that will allow me to align the glue block to the center of the material fairly easy. So we've got that, the glue block. We found the furthest forward point. We also know what the offset is from that point for the material. so the material take up from the spindle. Then we found our max length for the tailstock to travel. And then on top of that, I found the maximum length of material that I would be able to turn in between centers. Okay. Then from there, I measured from the spoil board to the center of the chuck, and that allowed me to know how big of a piece I can actually turn. That's pretty much your setup. I'll get this stuff all bolted down. Once I get it bolted down, I'll get the glue block glued onto the material, and then the material be cut to length. And then from there, I'll basically put the glue block in, tighten it down, align this point with the other end of the material square intersection point right in the center, tighten everything down to tighten the material in. You obviously clamp the glue block in there, and then you take this tailstock, you turn this handle, the tailstock comes out, and you'll pull that handle like that to lock it in place. And then you can just pull this handle up. It's spring loaded to get it out of the way so that you can get a better grip on it and not have it in the way of cutting. Okay, so there's that. Now the material's set up and you're ready to zero your tool and start carving a round design or a 3D design in a rotary fashion. Once again, this is set up in the X. You can repeat the same thing for the Y and get an even longer piece. If you're going to do something like that, I recommend setting up what are called through-hole Longworth chucks, and they have bearing setups on them that clamp around that will rotate and clamp around material. You can also use lathe centers that will look something like this, and it'll just support the material along the path. That's something you may have to kind of devise your own setups. I'm usually using longer, thicker wood, so I don't need them. But if I had to, what I would probably do is create something that clamped to probably the bottom of my extrusion here and followed the machine the length, and it would help stabilize the material so you don't get whip in the material as it's turning, and you don't get bowing in the material as it gets in the middle length where it's unsupported and the tool's pushing down, causing an offset tool path. So yeah, there's a little bit that goes into this, but it's pretty simple. Then we have our UCCNC. I go to my settings. I have my axis. I have my A axis is marked as a rotary axis. I have my steps per, because mine is a 6-to-1 unit. This is what my steps per are with my micro stepping, my velocity, my accelerations. I don't have my home pin on here, but I do have a home pin set up just so I can do I can actually do threading and everything like that. And I have it so it can roll over 360 degrees. So what that means is when I zero my rotary axis, it can actually rotate past that. If not, what it does is it stops at that furthest cut right before 360, and it spins all the way back around, and then allows you to spin again. So it depends on checking that or not checking that, depends on how far this rotary axis can go. On my trunnion table, because it has a rotary axis vertical and then a rocking rotary axis this way, I can't have my rocking rotary axis go past 360. It actually can't go past 270. But it allows me to set all that in UCCNC. Okay. In Gerbil, you don't have that. You kind of have to set all that information and just go from there. Gerbil's not really made for rotary. It works. Millwright has a rotary only or a rotary addition to their Gerbil setup. So yeah, as you can see, there's my B axis, and then I have my C axis if I need it. Okay. So that is the software part of it for the G-code sender. The only thing now is to actually put the design into Aspire, generate the G-code, and then cut material and start letting it eat. All right, later, guys.